Hello student, my name is Derivation. I am teaching you quantum mechanics BS.c third year. In quantum mechanics, Compton effect, derivation of the angular momentum from de Broglie equations. Number 3, derivation of the de Broglie equation. Number 1, derivation of the de Broglie equations. In case of photons, if it is assumed to have wave character, that according to Planck quantum theory, its energy is given by the expression E is equal to h nu, equation number 1, where nu is the frequency of the wave and the h is the Planck constant. Full stop. If the photon is supposed to have particle character, the according to the Einstein equation, its energy is equal to mc square, equation number 2, where m is the mass of photon, c is the velocity of the light. From equation 1st and 2nd, h nu is equal to mc square, nu is equal to c by lambda, is equal to h into c by lambda is equal to mc square, c से c cancel, h upon lambda is equal to mc or lambda is equal to h upon mc on page number 1. On page number 2, the above equation is applicable to material particle, full stop, if the mass and the velocity of the photon is replaced by the mass and velocity of material particle, full stop. Thus, for the material particle like electron, lambda is equal to h upon mv or lambda is equal to h upon p, because p is the momentum is equal to mass into velocity, where p is the momentum of the particle. The above equation is called the de Broglie equation and lambda is called the de Broglie wavelength. Number 2, derivation of the angular momentum from de Broglie equations. According to Bohr's model, the electrons revolves around the nucleus in a circular orbit, full stop. But according to the de Broglie concept, the electron is not only a particle but have a wave character also. If the wave is completely in phase, the circumference of the orbit must be equal to, on page number 2. On page number 3, an integral multiply of wavelength. Therefore, 2 pi r is equal to n lambda, where n is the integer and r is the radius of the orbit. Lambda is equal to h upon mv. So, 2 pi r is equal to nh upon mv or mvr is equal to nh upon 2 pi. This is basically Bohr's postulate of angular momentum, full stop, where n is the principal quantum number. Another important observation is that the number of waves an electron makes in a particular Bohr's orbit in one complete revolution is equal to the principal quantum number of that orbit. Number of waves n, 2 pi r upon lambda, 2 pi r upon lambda upon m into v is equal to 2 pi r into mv upon h, Planck constant. Problem: the electron is revolving around the nucleus in a circular orbit, full stop. How many revolutions it can make in 1 second? This is the problem on page number 3. On page number 4, answer: let the velocity of the electron be v meter per second. The distance it has to travel for one revolution is 2 pi r, bracket with the circumference of the circle, bracket closed. Thus the number of revolutions per second is equal to v upon 2 pi r. Compton effect. This is the very important. In 1923, A.H. Compton provided one more proof to the quantum theory or the photon theory. He was awarded Nobel Prize in 1927 for his discovery of what is now called the Compton effect. He demonstrated that when X-ray of wavelength lambda struck a sample of graphite, an electron was ejected and the X-ray scattered at angle theta had longer wavelength lambda. This is the very important definition. Explanation of the Compton effect. Compton said that it was like a ball hitting a stationary ball which is pushed away while the energy of the striking ball decreases. On page number 4. On page number 5, thus the argue the Alight radiation X-rays consist of particle photons, as a continuous wave could not have knocked out the electron. full stop. He visualized that a photon of incident light struck a stationary electron in graphite and hence lost some energy which resulted in the increase of wavelength. This process could not have occurred unless light radiation of the particle of photon. इसमें मैंने इलेक्ट्रॉन पर एक लाइट इंसिडेंट की है एक्सरे की, जिसकी वैल्यू लैम्डा है, और स्कैटर्ड इलेक्ट्रॉन ई दिखा शो किया गया है, और लैम्डा एंगल पर हॉरिजॉन्टल से लैम्डा प्लस डी लैम्डा वेवलेंथ पर एक्सरे स्कैटर्ड हुई है, और ये इलेक्ट्रॉन जो है इस एट रेस्ट है जिस पर इंसिडेंट एक्सरे हुई है. ये कॉम्पटन स्कैटरिंग ऑफ एक्सरे शो किया गया है. बाय एज्यूमिंग फोटोन इलेक्ट्रॉन collisions to be perfectly elastic, Compton found that the shift in wavelength, d lambda was given by the expression. On page number 5. On page number 6, d lambda is equal to 2h upon mc sin square theta by 2, where h is the Planck constant, m is the mass of the electron, full stop, c is the velocity of the light, and theta is the angle of scattering. The expression shows that d lambda is independent of the nature of the substance and the wavelength of the incident radiations. Given that the wavelength of the photon, one can calculate the momentum of electron ejected. That's all for today. Thank you.